This is the homework for 536 and 540. In problem 536, it is the end of the semester and the clubs at school are recording their profits. The science club started out with $20 and has increased its balance by an average of $10 per week. So it's starting with $20 and increasing by $10 per week. The math club has saved $5 per week after starting out with $50 at the beginning of the semester. So it's starting out with $50 and it's saving $5 per week. So remember, in a linear equation, y equals mx plus b form, the m is the amount being added or subtracted at a constant rate. B represents how much you're starting out with, the y-intercept. So this is the rate of change, or the growth rate, also known as slope. B is the initial value, what you're starting out with, or the y-intercept. So in problem 36, the x represents the time, the number of weeks, and the y is going to equal the total balance. So we want to put these two into linear equations. In part B, you need to graph both lines on one set of axes and determine when the clubs have the same balance. So in order to set this up, I labeled the balance as the dependent because the balance depends on how many weeks they've been saving. So the number of weeks, the x-axis, is the independent variable, and the balance is the dependent variable. The science club started with $20, so that is shown here, and they're saving $10 per week. So it increases by $10 for every week, $10 per week, and that is growing at a constant rate. The math club starts with $50 and is increasing by $5 per week. $5 per week, $5 per week. And if we continue this, we can see that the point of intersection is at 6 weeks and $80. So the clubs will have the same balance at 6 weeks. In part C, what is the balance at that point? The balance at that point is $80. In problem 540, we need to solve for x. One way of solving for x is to use the fraction buster method to eliminate the denominators in these first two terms. In order to do that, I want to find the least common multiple. The least common multiple is 10, and how I got that is because the multiples of 2 are 2, 4, 6, 8, 10, and the multiples of 5 are 5, 10, 15. And 10 is the first multiple that they have in common. So I'm going to use the least common multiple to eliminate the denominators. And I do that by multiplying every term by 10 on both sides of the equation. So I want to multiply this first term by 10, the second term by 10, and on the right side, this term by 10. And when you do that, you can cross-simplify. 10 divided by 2 is 5. 2 divided by 2 is 1. So that was the first term we multiplied by 10. And I wrote 10 as a fraction here. And then multiplying it by the second term, we can also cross-simplify. 10 divided by 5 is 2. 5 divided by 5 is 1. And you can see now that we have only 1s as the denominator. So anything divided by 1 is itself. So we've eliminated the denominator. And now we have 5 multiplied by x, 2 multiplied by x equals 1 multiplied by x. So 5 multiplied by x is 5x, 2 multiplied by x is 2x, and 1 multiplied by 10 is 10. Now we combine like terms. 5x plus 2x equals 10. Seven x equals 10. Inverse property multiplication is division. 7 divided by 7 equals 1 or 1x or x. 10 divided by 7 is 10 sevenths. In problem 540b, again we want to try to eliminate the denominators by finding the least common multiple. We're using the fraction buster method. So we need to find the least common multiple for 3 and 4. The least common multiple for 3 and 4 is 12. So I'm going to multiply both sides of the equation by 12. And remember, you have to multiply each term by 12. So we have 12 multiplied by the first term, 12 multiplied by the second term, and 12 multiplied by each term on the right side. So 12, and I'm going to write it as a fraction, 12 over 1. Now we can cross simplify. 12 divided by 3 is 4. 3 divided by 3 is 1. Cross simplify here as well. 12 divided by 4 is 3. 4 divided by 4 is 1. And you can see that we eliminated the denominators on the bottom because anything divided by 1 is itself. And then on the right side, 12, we're going to multiply each term on the right side by 12. And I have that written here, and I'm going to distribute that. And now, 4 multiplied by x is 4x. 3 multiplied by x. So you have to, again, remember, distribute to both terms. And then we have 12 multiplied by the quantity of 2 plus x. So I still have a lot of distributing still to complete. Now, 4 multiplied by x is 4x. 3 multiplied by x is 3x. 3 multiplied by negative 1 is negative 3. 12 multiplied by 2 is 24. And 12 multiplied by x is 12x. Now I'm going to combine like terms. 4x plus 3x is 7x. No like terms to combine on the right side. Inverse property of addition is subtraction, so I'm going to subtract 7x from both sides. And I'm bringing the x's to the right side because I have more positive x's on this right side. So I want to know what positive x equals, not a negative x. So I'm left with negative 3 equals 24. 12 minus 7x is 5x. Now, inverse property of addition. So to eliminate this positive 24, I'm going to subtract 24 from both sides of the equation. And remember, when you're adding two negatives, think of it as, I call it a dig-dig. You dig down 3 feet, you dig down 24 feet. So you keep digging down. So it's going to be a negative. And now we add those two together, it's going to be negative 27. Now we need to get x by itself. Inverse property of multiplication is division. Divide both sides by 5. Created the giant 1. Identity property of multiplication. What you do to one side, you do to the other. And we have negative 27 fifths equals x. And remember, we're looking for the value of x. So we write x first. X equals negative 27 fifths.